It's week 5, and today we're going to be talking about evaporation as part of our phase changes that we're going through this week. Our learning target is that we will be able to explain how substances move from the liquid to a gaseous state without reaching boiling point. So the clothes on this clothesline are soaking wet, but before too long they will be completely dry. How does this happen? Where does the water go? And what factors might help the clothes on the line dry more quickly? Well, evaporation explains why clothes dry on a clothesline. Evaporation is the process in which a liquid changes to a gas without becoming hot enough to boil. It occurs when individual liquid particles at the exposed surface of the liquid absorb just enough energy to overcome the force of attraction with other liquid particles. If the surface particles are moving in the right direction, they will pull away from the liquid and move into the air. So how can we speed up evaporation? Well, there are several ways that we can do this. We can increase the temperature of the liquid. A cup of hot water will evaporate more quickly than a cup of cold water. We can increase the surface area of the liquid. The same amount of water will evaporate more quickly in a wide, shallow bowl than in a tall, narrow glass. We can eliminate other substances in the liquid. For example, pure water will evaporate more quickly than salt water. We can decrease the evaporative substance in the air. Clothes will dry more quickly when the air itself contains very little water vapor. And we can increase air movement. Clothes on a clothesline will dry more quickly on a windy day than on a still day. Did you ever notice that when moving air cools you down, when it's hot out? For example, if you sit in front of a fan, you feel cooler. It's because moving air helps to evaporate the sweat on your skin. But why does the evaporation of sweat cool you down? Well, when a liquid such as sweat evaporates, energetic particles on the surface of the liquid escape into the air. After these particles leave, the remaining liquid has less energy. That energy happens to be in the form of heat. So you feel cooler. We call this evaporative cooling. So here's a question for you. On a hot day, high humidity makes you feel even hotter. Can you explain why? Think about it for a moment. High humidity makes you feel even hotter on a hot day. Why would that be? You can pause the video for a moment if you need extra time. Humidity is a measure of the amount of water vapor in the air. When humidity is high, sweat evaporates more slowly because there is already a lot of water vapor in the air. The slower evaporation rate reduces the potential for evaporative cooling. In other words, we feel hotter. So in summary, evaporation is the process in which a liquid changes to a gas without becoming hot enough to boil. It occurs only at the exposed surface of a liquid. Many factors affect how quickly a liquid evaporates, including the temperature of the liquid and air movement. Finally, when particles evaporate from the surface of a liquid, the remaining liquid is cooler because it has less energy. This is called evaporative cooling. One more time, let's look at our learning target. Students will be able to explain how substances move from the liquid to a gaseous state without reaching boiling point. If you can do that at this time, you're good to go. And you can work on the readings, the activities, and the questions that follow. However, if you need to look at this video one more time, you're more than welcome to go back and rewind it. Remember, stay healthy and stay happy. Have a great day. We'll talk to you later.